This is a classic boy-girl puzzle, beginning with a family, and they have 2 kids. So John called me the other day, and he had an assignment to do for class on probabilities. He was asked to solve 2 problems. A couple has 2 children, at least one of which is a boy. What is the probability that they have 2 boys? The other problem, a couple, probably the same couple, has 2 children, the older of which is a boy. What is the probability that they have 2 boys? But he hates calculating anything, so he called me to help him out. John, I said, let me show you how to do this without entering a single number. I mean it. You will not enter anything. You'll just simply answer some simple questions, true or false. Our Bayesian calculator is the ideal tool for lazy people like you who don't want to calculate. So, we think about this problem, and the very first thing we need to get straight is that we're going to encode the birth order, right? We know they have 2 kids, so they either have 2 boys, or a boy and then a girl, or a girl and then a boy, or 2 girls. So if we know nothing else, we can just say these are equally possible. Now, so we will enter a node, and we'll just write birth order is, and then we'll just put boy, 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 girl, girl, boy, girl, girl. And then we'll just hit enter. And Netica, knowing nothing else, will simply just look how many possibilities there are, and then divide by them. So there's 4. They're equiprobable, so they're 25% each. Done. Notice I have not entered a number. Okay, I just typed in the possible birth order, and that was it. So now let's consider the first problem. At least 1 boy. All right, so consider the possibility that they have at least 1 boy. In the absence of any knowledge, it's either true or false, but we can do better. So, right, it's in gray there because we're not saying that's a 50-50 chance. No. We're just saying, look, at least 1 boy, it's either true or false. We haven't figured out anything yet. It's just true or false. Come what may, it's either true or false. Now, what we will do, however, is we will link that node to what we know. We can link it to what we're given, namely that they have 2 kids. Okay, but we're not done. We need to enter a bit more of what we know. So this is what we've done. This is my node. And then this is my representation of they have at least 1 boy. And then there is this little arrow that goes from there to there. And that is absolutely crucial. And we will see why. So now that we have linked this, or these 2 nodes, right, Netica says, okay, well, tell me something. Tell me the following, all right? If the birth order is boy, boy, or boy, girl, or girl, boy, or girl, girl, tell me the state. Is this true or false? Okay, well, then that's what we'll do. And all I did is, and I'll show you how later, I said, okay, well, if the birth order is boy, boy, well, then at least 1 boy is true. Or if it's boy, girl, well, then yes, it's true. At least 1 boy. And girl, boy, yes, it's true. But if the birth order is girl, girl, well, then obviously there isn't at least 1 boy. That's going to be false. We are done. Notice I have not entered a single number. Okay, and now, as promised, I've calculated nothing myself. The revised probability is done by the Bayesian calculator. And it is indeed correct. In 3 of the 4 cases, there is at least 1 boy. Oh, That should be one. That should be singular, shouldn't it? Anyway, there we have it. So we've calculated, or rather, Netica has calculated. Netica is my Bayesian calculator. And it says, okay, well, then the probability that there's at least one boy is 75%. And is that right? Well, yeah, look, right? There's one boy here, and there's at least one boy here, and there's at least one boy here. And that's in 3 of the 4 cases. Done. Okay. But the question is, what is the probability that they have 2 boys, given that they have at least one boy? Okay. So now we're not just asking what's the probability that they have at least one boy. We're now given that they have at least one boy. Again, we calculate nothing. We just enter the evidence as true in green, and presto, the answer is 1/3. And that is what I've done. And I'll show you more actively in a bit. But that was the idea. I entered true. I said, okay, well, I have in fact observed the case, or I've been told, yes, it is true. They have at least one boy. And like magic, the answer came back and said, well, then there's a 33.3% chance that they have 2 boys. Notice that, as expected, this becomes 0. All right, if there's at least one boy, well, then there's no way they're going to have 2 girls. Another question then, which we treat just like we treated the other one. Now we are supposing that the oldest is a boy. So we start from fresh and we say, well, consider the first question. Actually, it's the second question, but never mind. Suppose the oldest is a boy. What's the probability that they have 2 boys? As before, we create a link to the other node and we say, okay, well, let us suppose that the oldest is a boy. Again, it's either true or false. And then we say, okay, as before, we fill in the truth table, right? All I do is I just enter what I know to be true or false. I calculate nothing. Again, I've not entered a single number. Clearly, if the birth order is boy, boy, then the oldest is a boy, etc., right? So if the birth order is boy, boy, well, then the oldest is a boy. Yep, because that tells me that the oldest is a boy. Over here, if the birth order is boy, girl, is the oldest a boy? Yes, that is true. But if the birth order is girl, boy, well then, oldest is a boy is false. And if the birth order is girl, girl, well then, oldest is a boy is false. Done. Next. Now we enter the actual finding, right? We enter what is actually given to us, namely that the oldest is in fact a boy. And we enter that in green, or rather that's the green node here. And our Bayesian calculator, which embodies, of course, well, what else, right? Bayes' theorem, goes to work and it calculates that the probability that they have 2 boys has gone from, right, it used to be 1/4 to now 50%. Done. For homework, a family has 2 children. Given that one is a boy and that he was born on a Tuesday, what is the probability that both children are boys? It's not 1/3 and it's not 1/2, but it is relevant. A detailed solution next time. I'm going to see how long it takes to recreate this particular little network. Very simple. Let's see. Let's hope it shouldn't take more than about 4 minutes. So let me show you. All right. So I go over here. You'll see I'm using Netica, but lots of other software does the exact same thing. So I'm going to create a node. And now I'm going to call this node. I'm going to call this node, well, it's birth order. All right, so it's birth order. And I'll be more precise here. Birth order is what? Well, it's one of four things. It's, we'll say, boy, or, and then we'll add another one, and we'll say what's or boy, girl, or, oh, of course we misspell that, or it could be girl, boy, or it could be girl, girl. I'll add another one just to show you something. We'll say boy, frog. What? Boy, frog? There's no such thing. Yes, I know. But this is to illustrate something. All right, now I'm going to say apply. Couldn't change now because birth order is, oh, of course. Okay, so I've already screwed up. Okay, birth order, because there's already a node that's being used. So I'll just say there. Is that better? Okay, it's better. There. Now, you'll wonder, what the hell is boy frog all about? Well, that is just to show you that, right, Netica doesn't care, nor should it care, about what I put in. So, of course, we've got this additional knowledge that, well, look, boy frog, whatever else is possible, that ain't possible. So I can just set this to 0. To 0. There we go. Okay, so now we've got this node is like this node, and all the other possibilities are covered. Boy frog is 0. No such thing, at least not on planet Earth. All right, now we need at least one boy. Well, then we'll create this node. And we'll say, all right, we'll say at least one. All right, at least one. All right, and we'll be more precise over here, and we'll say, okay, at least one boy. And here we'll just say, okay, it is either true or false. Okay, very good. At least one boy. It's either true or false. Well, it isn't linked yet, so it says, you know, that node is just kind of isolated. So we'll link it from there to there. Very good. But now we need to do something else. We need to look inside and look at its truth table. What does it know? Well, it doesn't know a whole lot. So it's actually going to be a function. It's going to be, winds up being really deterministic, right? And the idea is this. Okay, it's only going to be true or false. If the birth order is boy, boy, well then, is there at least one boy? Yes, that is true. Or if the birth order is boy, girl, at least one boy? Yes, that is true. Or if it's girl, boy, at least one boy? Yes, that is true. How about girl, girl? Well, no, that's false, right? Girl, girl, then there isn't at least one boy. And if it's boy, frog, well, we already said that's impossible. So we'll just say that's false. And now we'll say apply, and we are done. You'll notice that now, at least one boy, the initial probability, if we know nothing else, is that it's 75%, just like it is over here. Now, we can enter what we actually know. We are told, as a matter of fact, they do have at least one boy. So let us find out. Well, what's the probability they have two boys? Well, we go over here and we'll say, okay, well, it's true. We have found out. Yes, they have at least one boy. And we get this fabulous result that boy have the probability that they have two boys is indeed 33%. Has gone up from 25 to 33%. Very good. So I'll just remove all the findings here. Go back to this. By the way, right? If boy frog was possible, which it isn't, but still, notice that, oh, there being at least one boy would be 60% instead of 75. I know it's ridiculous, but it doesn't matter. It just This is just illustrative purposes. On some planet, maybe some people do give birth to a boy and then a frog. I don't know. Do you know? Okay. And if we find out, well, they actually have at least one boy, then, well, oh, that's interesting. Because of what we had filled out originally, we still get the desired result, which is 33%. Okay, we'll do that. And have I passed my 5-minute mark? No? Okay, oldest is a boy, so we'll do that one too. I'll do a node, and I'll go here. I'll just go a little lower here, and then I'll go, okay. So I will enter oldest. That's the name, the official name, but I'm going to be just a bit more descriptive here. Oldest is a boy. And now I will say, well, that is either true or it is false. Okay. And then we need to do, well, we'll make it, try to make it pretty. We'll go here. And then we need to link it. So we'll say, oh, add link. Okay, we'll add link. And we'll add a link to there, okay? Now, by the way, this is 0, so we might as well just put that to 0. Very good. And then we'll say, okay, well, let's look into the guts of this thing and let us see. Okay, well, tell me then, if the birth order is this, well then, is it true that the oldest is a boy? Well, hang on. We need to make this into a function. Okay, because we just want to say it's either true or false. We don't care about chance for the time being. Right? For the time being, we're just concerned about deterministic functions. Low. Okay, now, so what are we saying? So if the birth order is boy, boy, oldest is a boy? Yes. Right? Because here, the first one is a boy. If the birth order is boy, girl, oldest is a boy? Yes. If the birth order is girl, boy, is oldest a boy? No, because the first one is a girl, so the oldest is not a boy. That would be false. And if it's girl, girl, well, obviously it's not possible. And, oh, well, now that's an interesting possibility, right? If the birth order was boy, frog, is the oldest a boy? Well, okay, yes, it would be true, but okay, I'll just put that. But because boy frog is 0, it's not going to matter. And so we're going to go apply, close, and now we're done. Almost done. Now we find out, okay, well, if the oldest is a boy, suppose that is in fact given to us. Well, then we say true. And what do we find? Ah, mirabile dictu. Here we go, and it says, indeed, the probability of there being 2 boys is 50%, when given as evidence that the oldest is a boy. Notice that this additional boy frog here did not perturb us at all. Okay, well, this has been a little bit more than 5 minutes, but that's okay. We are done. Thank you for your patience. Oh, and next week, or maybe tomorrow, we'll find out why at least one boy born on Tuesday is actually computable. Okay, bye-bye.